Hi folks, this is question 7, so it's the first of the long questions. So the long questions were challenging this year. First part anyway. So this function gives us this her speed after she passes the point A. So the point A is the start, and then after that you put in value, you put in whatever amount of minutes you want for what her speed would be, up to 5 minutes. So it asks first part asks for her speed when she passes the point A. So when she passes the point A, that's 0 minutes after she passes time A. So you have to put in a 0 here for the first part. So v of 0 equals 2 over 3. You can see what's going to happen here. So the first 3 parts there are all just 0. So because they're just zeros being multiplied in. So 109. Yeah, that's the whatever it's in kilometers per hour. So she's going pretty fast. So that's her speed at point A. And then, like, if you want to know what speed she's doing after 1 minute, then you put in a 1. After second minute, you put in a 2. So that's what the question means. We'll probably have to do some of that now. Right, so part B, work out the acceleration. That's the rate. So the rate is important here. Hopefully you know that when you see rate, it'll mean that you'll be differentiating. So the rate at which her speed is increasing 5 minutes after she passes the point A. So we'll be subbing in 5 here, but we just need to differentiate the function first. So v dash t will be reduced down the power by 1, so and multiply. So that'll be 3 multiplied by 2 over 3, which will give you 2t, and then reduce down the power squared. Okay, minus 12t plus 13. So that's it differentiated. Then we just need to find v dash of 5 because it's for 5 minutes after. So 2 times 5 squared minus 12 times 5 plus 13, and you need to use your calculator. So you should get 3 in the end. So 3 kilometers per hour. So that's the rate. Right, so for maximum speed here, so whenever you see max or min, you know that you'll be differentiating, and we've already differentiated the last bit. So v dash t is equal to 2t squared minus 12t plus 13, and you should know at a max or a min that is always equal to 0. So we just have to solve here. Then you don't even need to put in that v dash t bit. All you have to do is just solve. We're just solving for t here, and whatever we get, that'll be the time that her speed will be, and that's it. Then we don't need to put it back in actually to get the actual speed. We don't need the speed, we just need the time at which our maximum speed happened. So we can't solve this by factorizing, so we need to do minus b formula. So it'll be minus 12 plus or minus square root, and then minus 12 squared minus 4 times 2 times 13 all over 2 times 2. So we should get 2 answers then. So you need to put both things into the calculator with a minus and a plus. So you'll get 2 answers. So one is 4.58, and the other one is 1.41 1.42, we'll just say, when you round it off. Yeah, so then you just need to get rid of one of them then. Alright, so if you think about it, the question was during the first 4 minutes. So obviously then we can't have the 4.8 because this is, so her, that she reached maximum speed there as well, but it was the 1.42 minutes that she reached it, so that between 1 and 4 minutes. So that's it. Okay, so use the integration to work out average speed. So when you see average in these integration questions, so you just have to go to the log tables, use that average formula. So that's 1 over b minus a and so on. And then the integral of whatever it is. So it's in this case it's 1 over, and it's from 5 minutes to 0 minutes. So we do 5 minus a is 0, 5 is b. So we do the integral of, and then it's just the function, so it's whatever the f of x is. So it's 2 over 3 t cubed minus 6t squared plus 13t plus 109. And then we're integrating it with respect to t. So we get 1 over 5 outside. And then this will become 2t to the power of 4 over, and it just becomes 12 because we're multiplying it by 4, minus, and then it's 6, it'll be 6t cubed over 3. So that'll be, that's just minus 2t cubed plus 13t squared over 2 plus 109t, and then that's between 5 and 0. Right, so then so 1 over 5, and so we just need to put in a 5 everywhere, so 2 times 5 to the power of 4 all over 12 minus 2 5 to the power of 3 plus 13 times 5 squared all over 2 plus 109 times by 5. Now we don't need to worry about the other because there's a t being multiplied in each one here, so you could minus and sub in 0 for t everywhere again for the 4 terms, but it'll be the same thing. So you can put all that in the calculator together, or might be better off just put what's inside the brackets first into the calculator and then divide it by 5 after. But so eventually you should get, if I've done it right beforehand, 112.33, so kilometers per hour. So that's her average speed then. Okay, so it's not too bad of a question so far. That's up to part D, and a few bits left to do. Right, so for this part, for part E, the first part tells us, so the first derivative of 1 is greater than 0. So what you have to know, and what that tells you, is that the whatever graph it is has to be going up, okay? So rising from left. Not writing this very well. Right, so it's rising from left to right, so I meant to write in there. So whichever one of our graphs, that could only be B, and it could only be D. They're the rising left to right. The other thing, what this tells us is that it has to be a local maximum, really, so it has to be rising upwards, okay? So basically it's a concave up, so it has to be bending upwards at that point. Okay, so the only one that's bending upwards at that point, so see the way graph B is coming, because it is bending upwards, the graph D is kind of, it's coming down and then going up afterwards. So the answer here is graph B. For, I assume they're asking which one it is. Where T, so write down which graph this is, so B, and then justify your answer using both v-1. Yeah, so something like that. I won't bother writing it in here because I've written it up there already. So in the first bit, you just have to write in that it tells us that it has to be rising from left to right. And then the second bit for v-1 is less than 0. It has to be bending upwards at that point. Okay, so the maximum has to be a local maximum at that point. And that's all you need to say for part E. Right, so for part F anyway, so it's an average speed zone, so you can't go over 100 kilometers. So it asks us the time. So when it asks you for time, in this case it's just going to be simple distance over speed. So if you do the distance over the speed, distance is just 10 kilometers, because you're only going 10 kilometers, and you're going like for it to get the minimum time, you would be going 100 kilometers. You wouldn't be allowed to go any higher, but you wouldn't be going any lower because we want the minimum time. So it's just over 100, so 10 over 100, and that's a tenth or 0.1, and then so 1/10 of an hour, so 1/10 of an hour is 66 minutes. So I'm just converting it into minutes, and that's it. That's all you have to do. So to be going, so for the 10 kilometers that you're going, you would have to get the minimum time. We want the minimum time. You have to go at 100 kilometers per hour exactly and stay on that, and you're covering 10 kilometers. So that's it. Part G then. Right, so this part is very tricky. So we can work out the distance that he goes first. So he passes the point A driving at a constant speed of 120 kilometers per hour. So he does 2 minutes of that. So if you do 120 times 2, that's 240. Yeah, and then divide by 60. And we're dividing by 60 to turn it into minutes, or sorry, into kilometers. So we get 4 kilometers. So so he's gone 4 kilometers. So if you're thinking of it from A to B, so that's A, and this is B here. So so he's gone 4 kilometers. So it's at 4 kilometers that he starts to decelerate, and so he's got 6 kilometers left for when he's decelerating. Now it's after 2 minutes as well that he starts to decelerate. So he notices that he's going too hard and he starts to decelerate. So if the average speed is going to be 100 kilometers per hour overall, then it has to take the same length of time as it did for the last part. And it took 6 minutes. Okay, so it took 6 minutes when they were just going 100 kilometers an hour all the time. So here, on average, in this part, it has to go 100 kilometers per hour on average, even though we know for the first 2 minutes it's harder, but it has to come down to be an average. So it has to still take the six more minutes. Sorry, it has to take 4 more minutes because 2 of them are gone already. So if you so altogether it'll be 6 minutes, but 2 of them are gone, so another 4. So uh, that should help us work out then the speed. So we have distance. Distance is on top here. Speed time is on the bottom in minutes. So we want the speed of his yeah, we want the speed that he's going at, so for the other 4 minutes. So we can get that by doing 6 over, and I'm going to keep this in hours, so we'll put 6 over 4 over 60. So 6 divided by 4 over 60. And you can put that in the calculator if you want. You should get 90 kilometers per hour. Right. So they want the final answer in kilometers per hour per minute. So I'm not sure if this is fully right. If you divide it by 4 for that, it'll give you 22.5 for the other 4 minutes. So kilometers per hour per minute. So I'll have to double check all that again. So that last question was very difficult. But it should be something along those lines at least. So that's question 7.